everyone. I'm going to start my lecture videos at section 5.4 and I may do previous sections, but for now I'll start at 5.4 and continue from there. I'm just using the chapter 5 slides. So section 5.4 is on conditional probability and the general multiplication rule. Conditional probability is just a different kind of probability, and we'll start with an example of that. On the next slide is describing conditional probability. The notation for conditional probability is P parentheses F slash E. And what that means is the probability that event F will occur given that event E has already occurred. So when you see that slash stands for that phrase, given that. So it just stands for given that. And in the problem, if you see that phrase, given that, then you're going to calculate a conditional probability. So the example that we'll do is on page 280. And it's a table that is showing the marital status of females and males, adults, in the U.S. in 2010. And so the table shows the totals for females and males. This column shows the marital status. And a question that we could answer from this table, for example, is what is the probability that a randomly selected U.S. adult was never married, given that the person is female? So the given part is that the person is female. So given that the person is female. And so the question is saying the given part is the person's female. So among all females in the U.S., what are the chances that we would pick out somebody who was never married, a female who was never married? So when calculating this, I always look for the given part. The given part is the person is female, and that's the part of the table that you'll focus on. I'm only going to use this column that's describing the female population in the U.S., and I'm not going to need any information about the male population or the totals, so I can just ignore the rest of the table. And in that column, the total of that column is 124.4, and in the probability, that's the denominator. The denominator is always the total. And then within that column, the number of females who are never married is 34 million. And so that is the numerator. So it's 34 divided by 124.4, that's 0.273. There's also, on the next slide, a formula for calculating conditional probability. And if you're comfortable using formulas, you're welcome to use it. This just means the probability of E and F occurring divided by the probability of E. And notice that the given part is always the denominator here. The N is just another way of saying the total number of. So it's just another way of saying it. This is saying the total number of things that are E and F, divide by the total number of E. And so you could use that formula. In this example up here, it's also written using the formula. The total number who are never married and female, divide by the total number who are female. But when I do these, I really prefer just to think of it in terms of the table and look at the given part and then look at the table, and that's the column or the row that you'll use when answering the question. I'm going to stay with the same example and just show a few other things we could answer with this table. And some of it is review from previous sections. So for example, if it asked, what's the probability that a randomly selected U.S. adult is female? This is a question from section 5.2. So the chances that somebody would be female, we would look for the total of the female population, 124.4, divide by 242.2, the total of all the U.S. The second example is also similar to what you saw in section 5.2. What are the chances that we select a U.S. adult who is divorced? And so you look for the total number who are divorced, 23.8 million. And you still divide it by the total of all of the U.S. adults. Here's another question we could answer. What's the probability a randomly selected U.S. adult is a divorced female? In other words, somebody who's divorced and female. In the table, the denominator is still going to be 242.2. But now we want to look for the number of people who are both female and divorced. So that would be 13.8 million that are female and they're divorced. So 13.8 divided by the total, 242.2. Here's another question. What's the probability that we select an adult and that person is female or divorced? And the key word here is or. And remember that when you see the word or, you're going to end up adding probabilities. And in fact, you have to add the two probabilities and then subtract the overlap. So the probability that a person is female, which is the 124.4 divided by 242.2 plus the probability that a person is divorced, and so that's 23.8 divided by 242.2 minus the probability the person is divorced and female. So that's 13.8 divided by 242.2. And I won't calculate this right now, but you would add the two fractions and subtract this fraction, and that would give you that probability. And then two last examples. What's the probability that we select a U.S. adult that's male given that the person is married? So the key phrase there is given that. That means that this is going to be a conditional probability. conditional probability, we'll write it this way: probability the person is male given that they are married. So the given part is that the person is married, and that means that on the table, all we're concerned with is the section of the table about married people. So just this section here, just this row. And in that row, the total of that row is 124.2. And that's going to be the denominator, 124.2. And the numerator, let's see, so in that row of married people, the number of people who are male in that row is 62.2. So that will be the numerator, 62.2. And if you work that out as a decimal, that comes out to about 0.5008. Last one. What's the chances that a randomly selected adult is separated given that the person is male? So this is another conditional probability. You have that phrase given that. So I'm going to write it out as the probability a person is separated given that the person is male. Now the given part is that the person is male. And that means that on the table, I'm only focusing on the column, in this case, of all males. And I'm not going to need to know the female column or the total column. So within that column, the total of that column is 117.8. That's going to be my denominator. And within that column, within the male column, the number of males who are separated is 2.4. And that's the numerator, 2.4. So I'll calculate that. Let's see what that comes out to. .0204. Alright, we'll continue with this section in the next video.